Alrighty, we are gonna get into it. We're gonna have altercations and stuff. I didn't turn off my word. Ignore that. I need my other Word document up though. Game dev knowledge. Did you know red is the x-axis? Anyways, programming lingo. Did you know new is used for just one code? That's temporary. You probably didn't know. Probably just like, what? What are you talking about? Yo, what's going on? What? Anyways, this is American Idol, but not really. We gotta make a plane fly, apparently. This is, Player Control, Unit 1, is what it's called. Well, actually, that's just the whole project in general. I don't know why I read it like that. This is, Tutorial Challenge 1, Plane Programming. So, I don't know if I should just make a... Okay, they have a starting file thing. Let me just save that first. Where are we? Create with code. Challenge 1 starter files. Okay, so, let's listen in on what they want us to do in this new winter look.
Welcome to your very first challenge. In these challenges, you'll be given a new project, but it will be filled with bugs that you'll have to fix and missing features that you'll have to implement. The goal here is to take the skills you learned in the unit and put them to the test in a different environment. For example, in the first unit, you learned to program a car that could drive down a road. In this challenge, though, you're not going to program a car, you'll program a plane. And this plane is going to come with all kinds of issues. It flies backwards instead of forwards, you can't steer it, and it goes like 1,000,000 miles an hour just in circles. It's basically a nightmare, and you are in charge of fixing it. Don't worry though, if you think about it, the programming required to steer a plane is not too different from the programming you did to steer that car. You know how to make objects move forward, you know how to rotate them based on user input. That's pretty much all you'll need to know to program this plane. Plus, you can always reference the code from your prototype, and we've also provided you with some helpful hints if you get stuck. In addition to the main challenges, you'll also have the option of completing bonus challenges. These bonus challenges require you to go just a bit above and beyond what you learned in the unit and apply your skills in completely new ways. You may even have to do a bit of online research to figure these out. So if you do complete a bonus challenge, you should give yourself a pat on the back. Now, during these challenges, you may be tempted to throw up your hands and quit. They're not easy, but my advice, don't give up. If you take the time to troubleshoot the issues and work through these challenges, your Unity and programming skills will be at a new level when you get to the other side. So to make all that happen, I'll see you in Unity. Welcome to Challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this vehicle that can drive forward and these boxes that have physics and collisions in it, and we can fully control this vehicle, turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game,
And if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed. We have our camera over on this nice side view so we can see our plane flying around and we can fly through all these obstacles, and we're following the plane really nicely. So, this is what our challenge should look like by the end. And this is what our project looks like now. Oh my gosh, the plane just flew straight backwards. It's like, it just keeps going incredibly fast. That's far too fast for us to be able to do anything. Oh my gosh, just flying straight up all the way directly into the air. Well, that's not good. Can I even control this? No. That's really frustrating. For some reason, our camera also has this weird front view, and it doesn't even look like we're following the plane at all. I don't even know where the plane is. It's gone. That's frustrating. Okay. Now, on our challenge page, below the video, you can see that there's all of these different steps that we can go through to make our project complete. You can see here listed the entire step that you have to do. So the problem is the plane is going backwards. What we need to do is make the plane go forwards. And if you get stuck, there are these helpful hints at the bottom of each step to help provide you with a little bit of insight as to how you can fix the problem in case you get stuck. Our next step, the plane is going too fast, so we need to slow it down. The camera is in front of the plane, so we need to reposition it. Our camera is also not following the plane at all, which isn't very helpful. And our plane is tilting automatically. So, in order to get our project to a complete state, we need to make sure that we go through each of these different steps. And something helpful that you can do as you complete each one, for example, if you finish watching this video, you can mark the step as completed. And then if you fix the plane going backwards, you can mark it as complete. If you found you actually broke something, you can mark it as incomplete so you can keep track of your progress. In addition to our main problems with our project, we've also added in bonus challenge problems that you can try and solve to see what you understand about Unity and push your knowledge just a little bit further. So, in our completed project, you can see if I press play, and then I'll just pause this game really quick. And then actually, if I go focus in on the player, we'll get it to the side. I'm going to step through, and if you watch the propeller, you'll see that the propeller actually rotates as the game is playing. So that's a cool, fun little feature that you can try and do yourself. The bonus challenges are designed to be a bit more difficult than what you know and understand. There are hints that help you along the way in case you want to give it a try and see what you can do. In addition, if you do get stuck, feel free to use the internet. There are so many different resources that you can use just looking it up on Google. So for example, if I want to figure out how I can make an object rotate in Unity, there's a little tutorial that you could do for spinning a cube that's very similar. Somebody asked a question on Stack Overflow about rotating an object that might have some good advice on how you should approach it. This is kind of an interesting one. How do I rotate an object around its center in a script? Very similar to what you're trying to do. In addition, these challenges are also a great opportunity to take a look at the documentation. So here is actually the documentation about how transform.rotate works. That goes in depth about all of the different ways that you can use the rotate tool and the rotate method. It even has some examples that you can take a look at. So if you want to see different ways that you can rotate something, it's a good place to go. And you can also see all of the other different options. For example, vector 3, of all of the different vector 3s that you could potentially use. So that way, you can start digging a little bit more into all of the different ways that you can use all of the different methods and the different classes in Unity to be able to create your projects. In our starter project, you can see that when I press play, and hopefully if I can pause really fast, all right, I hope our player, they're out in the distance, so I'm just going to focus in. So you can see if I step through, hopefully the plane stays in view. the propeller is never actually moving. So that's a problem. Now, if you do get stuck, inside of your challenge folder, there's a set of instructions that you can use. And inside of the instructions, if we click on the challenge 1 outcome, and in fact, in our inspector, you can see this little gray bar down here. And if we actually just drag this up by clicking on that gray bar, you can see there's actually this little video. And if you press the play button, you can see exactly how we were trying to make our plane and our game work before. Now, a lot of the things we were trying to do before are very similar to how we set up our initial project that we made, our prototype 1. So if you ever get confused or get lost, you can feel free to reference your prototype, take a look at your scripts, see the different things that we set up in our scripts to understand what's going wrong inside of our challenges. Another really helpful thing in our challenges is in the scripts folder. All of the scripts actually have an X at the end of the name, so that way you know that this is our challenge script versus the names of the scripts that we had before.
To get started, download the challenge assets using the link below the video.
It will prompt you to download your challenge file, and then if you want to add that asset package to your project, you can go to the top left of Unity, click the Assets button, Import Package, Custom Package, which will then bring up your File Explorer, and then just go to the folder where you have that package saved, click on it, click Open, click on the Import button when it gives you the prompt on the window, and it will download that package to your project. So, get started on your first challenge, and good luck.
Okay. Well, I was just getting some other Unity junk set up right away. Because I know I'm already going to have to use it, so, you know, might as well get Unity project up, since that takes a while to load, and I got Visual Studio up too, for our actual programming. And let me swap over to that. Just throw this down here. Okay, and I had not done it yet, so I'm going to make a little tab on my programming section here. Got advanced scripts. Want to also make a follow player. Right now, all I am doing is making a, in my Word document, I'm just making titles, and then putting the code under the titles so I know what I used. Like, oh, this code makes you follow the player. This code lets you control the player. And then it's just so I know what I used. And then I can base things off those. And use the vocabulary that I took notes on to go, oh, I need to do this to be able to do that. So that should hopefully help me a little bit, is the idea. Why does this seem so loud? It's just a loud song. It's just a loud song. Okay, so... Warning. When you import the challenge into your project, it is supposed to have bugs. The purpose of the challenge is for you to fix those bugs which are listed below. There are also hints at the bottom of the page to help you if you get stuck. If you cannot fix the bugs and wish to delete the challenge files from your project in the project window, select delete. Good luck. Okay. The plane is going backwards. Make the plane go forward. The plane is going too fast. Slow the plane down to a manageable speed. The plane is tilting automatically. Make the plane tilt only if the user presses up or down arrows. The camera is in front of the plane. Reposition it so it's behind the plane. I mean beside the plane. The camera is not following the plane. Make the camera follow the plane. Bonus. The plane's propeller does not spin. Create a script that spins the plane's propeller. And then they have all of these hints. Optional step. What? Even more challenges? You can challenge yourself even more by attempting to add special bonus features to your main prototype, which range from easy to expert in difficulty. These are extra bonus challenges and are entirely optional. Interested and just want to continue the course, simply mark this step complete and move to the next. If you are interested, check out bonus feature tutorial and remember to return here when you're done. Keep learning. I'm just curious, if I click on this, does it like bring you to... Local multiplayer? Instant solution. This sounds like it might be interesting. We'll keep that up. I don't know if I'll get to that tonight, because how long is this one? It says it's an hour. Yeah, we might not get to that tonight. But let's start going through these steps. So the plane is going backward. Let's first bring up the plane thing in this in general, because we don't even have it up. Okay. Oh, it's still loading. Okay. So I got all those scripts up. Let's see. We're using like the same mountainous background, more or less. You got these little objectuals. Where even is the camera right now? There's the camera. Okay, well, let's see. Let's like position it right here. Oh, that's silly. They made this easy by making it two different objects and connecting them together. They didn't have to do that. That's very nice of them. That's very nice. Okay, so let us look at their stuff. This is player control X and follow player X. So right now we know our main problem is it's going backwards, right? That's the main one we're on right now. Yeah, plane is going backwards. So that would be under player control. I'll look at the script right now. We have, so I got player control, the one that I made. And we have speed, turn speed, horizontal input, forward input. And right now, their public floats are speed, rotation speed, and vertical input. Okay, that makes sense because they're going vertical, right? We got a little comments in here. So we got, get the user's vertical input, move the plane forward at a constant rate, tilt the plane up, down, based on up-down arrow keys. Let me just make sure the things are spelled right first. Vertical. Vertical. That looks correct. Okay, so we want the vertical input to be in here. It's not in here. So we have vector 3 right. Vector 3 forward. Time dilate. We want to times it by there. Vertical input. So right now it's multiplying by rotation speed. Rotate. Rotation speed. Well, no, if you mess up the order of operations, that messes everything else up, right? Rotation speed is a variable, though, so we can change that there. But I think we want it here. Just out of curiosity, let's see how this looks first. Hmm. Hmm. Apparently it's still going back. Change these to 1. Well, it's going a lot slower. It's still going too fast. This one doesn't even like have anything. Oh. Critical input, rotation speed, time delta. Oh. I see what I did wrong now. This is the one going back. Wait, look at this now. Huh. And I'm not doing that because... Or was it doing it because of my input? No, it's still honoring the input. Just a bubble. Just a bubble. It's a bubble. Okay, so... We got it to fly forward. Plane is flying forward. Plane is going too fast. I'd say we have it at a manageable speed already. But I should probably change delta time. Oh, I read that wrong. It's time delta time. Don't we want this to be on the vertical input also, though? Or no? Well, let's see what it does first. I think it's rotating it. Yeah, it was definitely rotating it. But it's rotating it left and right, and not up and down. We want it to rotate up and down. We want it to rotate like that, which is the x-axis on the rotation. X-axis is red. What's the offset? Plane is going too fast. We don't have to worry about that. It's wicked slow right now. Plane is tilting automatically. That's not happening. Camera is in front of the plane. Not in front of the plane. Camera is not following the plane. Not done that. I like how this doesn't tell you to make the plane actually move up and down. What was it under again? Input manager. Vertical is up and down. So we want it to control it going up and down. On the x-axis. I don't want it to be vector up. I want it to be something else. What is this supposed to be? Give me some suggestions. That's not what I want. Oh, it needs to be right. It's moving. Okay. Well, that gives us the control over the plane. Probably make that a little more. But now we need the camera to follow the plane. So, the plane can move forward. The plane is moving at a speed that is manageable to control. Right now we have like a flash game in front of us. As soon as you hit the play button, the plane is on the way. You got an endless runner. You can't control it. Flappy Bird is right here. Everyone's gonna get mad at it and kill people over it. It's great. And some guy's gonna get a ton of money and not care about you. And everything is cool. But we want this position to be kept. So... 1711 seems good. If the camera rotates, it rotates like that. I just need to rotate it on the... What axis am I rotating on? Looks like Y. Looks pretty good. Okay, so we want to offset it by that much. So we need to offset the rotation and the position. So for our follow player camera, we only had to offset the one position. So let's see, we got follow player, mono behavior, public game object plane. Okay, well first, it's not named correctly. Player. Actually, we shouldn't have it like that. We can have it be plane still. We can just name this to plane. Well. Okay, we don't define one. Yeah, that'd be easier. Or just making sure me naming that plane is not gonna mess it up. Let me look at something. No interest. Save that. Save that. Okay. So the game object is now plane. Oh yeah, we can define it differently. Okay. But yeah, now that is added there correctly. So now it knows that the game object plane is our plane. And it has an offset vector. But the offset vector is not defined at all. call this offset, we have to offset the Y. We'll call this offset P. And we have to define how it's offset. P equals new vector 3, and it is 17 1 1 parentheses semicolon, then private vector 3 offset R equals new vector 3. We want this one 0, negative 95, and 0. Correct? Correct. Scaling is fine. And then semicolon. So now offset P and offset R both exist. So with this, transform position, it equals player, this equals the plane, transform position, and it's adding into offset, except we want this to add into offset P now. And then was oh, are they saying because it's nothing's looking at it right now? Oh yeah. For this, we want is it rotation or rotate? Rotate. Oh, it's capital R, that's why. Equal. How did this one work? Transform, translate. Position. Following the player's transformation position. So you'd want to also follow the player's transformation. Rotate, right? Position is not capitalized though. Translating that R. I don't know if I'm gonna rate this right. I guess I can just rate it and see if it works. Transform, rotate. So what we're telling the camera to do right now, what we're telling the camera to do in the basic one is it's transforming its position to the player's transform position plus the offset. So we want it to transform rotate to the player's transform rotate. Plus our off set to R. Transform attached to this game object. Cannot assign rotate because it is a method group. Let's see what I want. It'll rotate. Is that how I'd want that? Transform does not contain a definition for rotate, and no accessible extension method rotate accepting the first arc transform. How would I write this then? We should review angles and degrees relative to Thinking. Confused. Let me delete this really quick. And see what this does right now. Wait, when was this error? That was a while ago. It's probably not important. Okay, maybe I was thinking too much. I thought it was not going to follow the plane for some reason. But that is following the plan. Do I want to up these more? And my up key doesn't work. Try that. So what if I made this like, I don't know, 40? Oh yeah, I guess it just is heavy as an object. I don't know. I'll make it 50 and make this 25. Yeah. It's probably fun, but that feels a lot more smooth controlling it. maybe 55. Or I made it too fast. Okay, well, now it's just a challenging Flappy Bird game. Well, there, I cleared it. Okay, well, video game is made. Camera is following the plane now. I guess I made that more complicated than I thought it would be. Oh yeah, I know what I did. The plane's position, I mean, the camera's position is not changed. Whatever I had it set to, the rotation's going to stay at unless I change the rotation. So it's following the position at the rotation that it was already at in the first place, so I'm just stupid. That's why I didn't need to change it. That being said, if I need to change the camera angles for a different sort of game, then I would need to do something like that, and I don't know how to. But we won't worry about that right now. Create a script that spins the plane's propeller. This seems pretty simple, so I'll just do it. More so because the plane already has a script. I mean, the propeller already has a individual thing for it. Propeller, oh yeah. Propeller spin. Okay. And we will drag that over there. Propeller spin is now in our little doodle mop there. And we'll open up our propeller spin. So, this is pretty simple. We're just going to rotate it, right? Though we would want to rotate it based on... Well, I guess we don't need to. It's always moving forward when we hit enter. So it doesn't really need to be that complicated. It's always flying. So let me think. I don't want to do this. So, first, just so I am not stupid, I want it to rotate on the z-axis. The z-axis needs to rotate. We need to make the z-axis rotate. So we just need to do this whole entire formula. What is the yeah, the interval is... That's just so it doesn't do it at wicked high speed. The rotation speed just so you can control it. So we probably want that so it doesn't look like it's spinning out of control, I guess. I can make that private, right? Transform. Vector 3. Rotating blue, which is Z. Z is the last in line. So okay, 200 forward. Times time. Delta time. And we want it to go by rotation speed. And semicolon. And save. Now when we go in here, oh yeah. I'm the dummy that made it. Well. I'll just make it public. I'm just dummy. I'll make this 10. Okay, the propeller is moving. It's just very slow. A very slow propeller. So we'll make it 100. That is still a pretty slow propeller for it to be flying this, so we'll make it 500. That is a nice faster propeller. It's still pretty slow. I'll just make it 1,000, see what it looks like. That looks pretty decent. I suppose if you were an artist and you were doing something like this, you'd be like, well, what moving parts would I need on this? And then you would separate it in layers, right? It would be like a VTuber model, essentially. That's a good way to think of it. Because you want those separated into layers so you can move them differently and have the bones in there differently. That's interesting. It's very interesting. But let's change this to 1,500 and see how fast that is. Okay, that looks a bit better. I want it to look like it's actually propelling the plane forward, not just like some cheap little thing. Oh yeah. The propeller is technically pulling the plane forward now, but we're rotating in it. And it's rotating the larger mass with it. I mean, I guess that's not a big deal. But it makes the plane do this when you're not controlling it. You can still control it though in general. How would I make it just rotate then? Not pull it forward? Or is that just impossible? Wait, why is it pulling it forward? Because all it should be doing is spinning. All it should be doing is spinning. Can't show them individually. But the plane... Well, the plane is connected to the... The propeller is connected to the plane. So I would need to take it out of it, right? Can I, like, exempt properties from it? Because what it means is these two scripts are applying to that one. So I want to... I want to name it. What would it be? Would I just say tree? Would I say tree? Maybe? I don't know. Would it be a tree? A good old little tree? Huh. I want it to not apply to this. I want this to not have the same scripts applied to it as the plane. Unity, don't apply scripts to child. Oop, this seems like what I want. I need to enable and disable all scripts in the children of a parent game object. Some objects are the parents of other children. Also, I need it to be fast and seamless, so I don't think I can use... Fine, because there are a lot of objects. Is this possible? Use a static collection list. A list, for example, to contain references to all these objects. Then call a function method that will iterate through that collection and set each of these objects to disable. The list type should likely be something general. If you're working with a good variety of different types, so at the scene's loading, have all the objects add themselves to this list, or use a find call to find them all. At the start of the scene, you should only need to do this once, so from there on, getting access to all of them will be fairly simple. Get component calls also tend to be fairly costly, so keeping this manifest of these objects, making sure you've kept track of the locations of its members within it, so you know which ones to activate, deactivate, will improve speed dramatically. For example, public static list. Find object. Fastest way to be set active on a parent object. Scripts to disable, for instance, attach them all to an empty game object within the parent and just set that to inactive, which will in turn control the empty object and all of its children. You can find all components that can be disabled by doing array of all children in parent by doing. Oh. Wait, they're doing it in JavaScript though, but they're asking on Unity? What? I saw someone mentioning this before. Offers several approaches to resolving a reference to a game object in the scene. A common choice is to use the game object's name, either a game object find method, which will look through all the objects in the scene, or by searching through the names of another game object's children for a match. Both of these options are bad practices. Let's look at a small example. Here's the UI. Here's a script that makes some text display how many objects are inside scene's UI canvas. The script introduces a number of problems. Grab an object in the scene called canvas, some text and a child object of the script attached to. On every frame, modify that text. A better approach. Certainly, this way we know exactly what a script needs when we attach it. To do this, let's make fields public. Just like making things public, and you can use serialized field attribute instead to make your private variables available to edit in the inspector. Yeah, there was a way to just do that normally. I'm gonna write that down. Serialized field. Serialized field. Okay. And script component. And script derived from on behavior. Disable a script when object has a child. How do I deactivate a parent and its children? Disabling a script. No, I want to disable the child script on that being applied. Indeed, disable parent game object. Enable a child game object. Anyway, I think this might be what I want. You could either set the child's parents to normal. As soon as the game starts, this would be the best run performance, and it'll still look clean and organized while in edit mode. Make sure you assign the children and the inspector here. Try to avoid awake. Sets each child's parent to null while keeping their world position. Child and children. Set parent null true. Or you could store their positions in a list and constantly update them in fixed update. Very bad on performance as opposed to the other method due to the constant matrix calculations. And lastly, you could save the world positions at the start of the game reference this. Oh. I'm curious to see if this works really quick. Someone said just add a rigid body to it and its body type to static. What if I do that? What does this do? Okay, that's kind of what I thought it would do. Plane is constantly, well, that part of the plane is constantly rotating. It's not moving that way, though. I mean, I guess in theory it flies like a real plane if it's pulling up slightly. So I could just say it's fine. That's what a plane would really do unless you turn off the engines, and you can't turn off the engines in this. So, I don't know. I can just say it's fine. Good enough. Maybe. Good enough, maybe? Question mark? You could add running and I didn't see where they said add it to make it static. But, create a script that spins the propeller. The propeller is spinning, so, I don't know. The propeller is spinning. It's doing it. I mean, sure. Inspiring. Very inspiring. So, let's look at this bonus one really quick. In this tutorial, you can go way above and beyond what you learned in this unit and share what you've made with your fellow creators. There are 4 bonus features presented in the tutorial, marked as easy, medium, hard, and expert. You can attempt any number of these, put your own spin on them, and then share your work. The tutorial is entirely optional, but highly recommended for anyone wishing to take their skills to a new level. Obstacle pyramids. I did do that already. Pretty easy. None of them or all of them. Okay. Create stacks and piles, pyramids, and obstacles to drive through. This will be more satisfying for a player to crash into compared to a single object. I already did that. I made a little stack of the oil drum things. Oncoming vehicles. Add a couple of other cars that are automatically driving down the road in the opposite direction, which the player also has to avoid. This will make the experience more challenging, and so the player will be forced to think quickly rather than times they need. Allow the player to press a key on the keyboard to switch camera views. Ideally, the same key would toggle between 2 views, one behind. True. I could do something like that. I'm just kind of curious to see what they had for this bonus content that you don't need to do. See what they got going on. Ooh. Do. Transform this into a local multiplayer split screen game with 2 cars, where one player's car is controlled by WSD and the other's arrow keys. This would add a completely new competitive dimension to the prototype. You'll need to edit the input manager and the camera's viewpoint react with the draw property. Add a second camera and then use a key to press to enable and disable it. Share your work. I'm curious to look at it, but we'll deal with that more later. Project design. Document. Okay, well, let's see what this thing is all about first. No clue. No clue what we got going on. Blah, blah, blah. Let me just make sure that's saved. Make sure script stuff is saved, and then I will mute stuff, and we'll start this.
Welcome to your very first lab session, where you will begin working on your own personal projects. Unlike the prototypes, where we are working on the same type of project together, in these labs, you'll be working on your own project, which will be completely different from mine. You have the great power of coming up with a unique concept for your project. But as you know, with great power comes great responsibility. You are responsible for making sure you actually finish it. You need to take the time to think through your idea and plan out how you'll get it done. So by the end of this lesson, you will have completed a design document for your project, including an outline of the concept and timeline for completing it. Here's the tricky thing about coming up with a concept for your project. On one hand, you want it to be unique and amazing and like nothing the world has ever seen. On the other hand, you want it to be complete and functional and playable. You want all of these things, but unfortunately, they're kind of at odds. Now, don't get me wrong, it is possible to create a unique, amazing project like nothing the world has ever seen that is also complete, functional, and playable, but it would just take a lot of time. And I don't mean hours or days, I mean years. And maybe not just years of your life, years of other people's lives. To make some of the console games you might have played before, it can literally take hundreds of people, thousands of hours, which means we're talking about hundreds of thousands of human hours to make some of these products. So given that, the trick here is figuring out how much time you have to dedicate to this project, then striking a balance between uniqueness and completeness to get the best possible outcome. Here are 2 tips for how you can do that. First, in this course, as you create different prototypes, you'll learn how to program a ton of awesome different features. So why not build on those features that you'll already know how to program instead of having to figure out everything from scratch? The second thing we'll do to make sure we actually complete what we set out to do is not try to make a full-featured, production-ready, highly polished project. Instead, our goal will be to make a minimum viable product, or MVP. A minimum viable product is a version of your project that has enough features and looks good enough to satisfy early users, allowing you to get feedback for future development. So in completing this design document, recognize your time constraints, build on the features you have, and aim for an amazing minimum viable product. Now let's start creating.
Welcome to the lab, where you'll be working on your personal project. Now, personal projects are designed for you to work on your own with less instruction. So it's a chance to create a project that you really care about and can be really creative with to make whatever you want. They're a great opportunity to apply and solidify the skills that you learned in the lessons and in the challenges. Let's take a look at my personal project. So we've created this endless running game where we have a deer being chased by different animals and obstacles like rocks. Our screen scrolls endlessly, and the whole objective is to last as long as possible, collecting different hearts and trying to stay alive. And then we can even restart our game to try again. Now, these personal projects are designed to be built on top of all of the different things that you learn from each individual unit and each individual challenge. Consider Prototype 1, where we learned how to create our first project, and we really get to learn a lot about player input that we then apply into our challenge. And so we can have our player move this vehicle around using the arrow keys to turn and to move forwards and backwards. In our second prototype, we'll get to learn about the basic gameplay to be able to create all of these animals that spawn down the scene. We even get to learn about how we can spawn obstacles and projectiles based on the player's input, and learning a little bit about collisions along the way. In our third prototype, we take our projects a little bit further using sound effects and animations to make our games really cool. Look at that jumping animation. This farmer's so excited, running through the forest, and then we can collide with these different obstacles, create this huge puff of smoke. In our fourth prototype, we'll get to learn about the different gameplay mechanics, the power-ups, increasing difficulty, so we need to avoid these enemy spheres coming at us and stay alive. Get these power-ups so that we can bump them away if we need to, and then eventually make the power-up go away, until finally we can bring all of these different parts together to be able to make a full game with really cool effects, with nice user interface, to be able to set difficulty states, interact with different objects, accumulate score, and even lose the game. Now, the goal of our personal projects is all focused on two things: the completeness of our game, so how much of what we actually completed is what we intended to finish, and then the creative or applicable ways that we made our game. So how much new things did we learn or add to our game to either work really well or look really nice? And then did we apply the skills that we learned to be able to make something that's our own? Now, these two things are always in constant balance of each other, and so at some point you have to decide when your game is exactly what you wanted it to be, but also, is it good enough to share with other people? So taking a look at what I set out to do with my own personal project, I have this handy design document that helps to outline the different minimal things that I'm trying to complete, known as a minimum viable product. Now, at the end of the day, my game definitely could use a lot more work, but to see where we started off with, I wanted to create a game where the player could control a deer in a top-down style game using the arrow keys to move the player in a bunch of directions around the screen. For my gameplay, I wanted animals and obstacles to appear from the top of the screen, and the goal of the game was to avoid crashing into the different rocks or being eaten by foxes and getting bit. For the sound and effects, I wanted sound effects to happen when I bumped into other animals, if I crashed into a rock, or if I got bitten by a fox. For the particle effects, I wanted them to pop up whenever I crashed into a rock. And then I wanted to hopefully get a scrolling background to make it look like all the animals are running really quickly. For the gameplay and the mechanics of my game, I wanted the game to progress whenever waves of foxes bit the player and attempted to attack, so that it made the game a bit more difficult to stay alive. I also wanted to put in hearts that appeared so that the player could regain their health back. In terms of what I wanted the user to experience, I wanted their lives to decrease whenever they were hit by a rock or bitten by a fox. And then at the start of the game, we'd have our "Oh dear" title screen that would appear, and our game would end when the player ran out of lives. There's even other additional features, which is the point where you can kind of stretch your ideas and your imagination to see what you can do. And so some features that I wanted to add so people would bounce off of larger animals, making it harder to control the player and avoid all the obstacles that are in our game. Now, with this minimum viable product that I wanted to complete, in the design document that we provide, there will be a timeline to help outline the things that you want to accomplish every day, every week, with the different features that you want to add to your game. So you can see in my outline, I wanted to set up my camera, and then I wanted to move the player, and then I wanted objects to spawn randomly. I added in some collisions. Eventually, I moved away from just having these primitive spheres and cubes on the scene, and I replaced them with some actual assets that I could use to make my game feel a little bit cooler. After that, I added in some of the different gameplay pieces like health and game over. After that, I polished my game up a little bit more, adding in some of those particle and sound effects, that scrolling background, and that music. And then if I was able to, I would add in different power-up objects to make the player jump or to save the high scores of all my different players. So you're trying to get to a point with your project where your game will have just enough to be fun and be enjoyable, but also give you opportunities to get feedback from other people, like your friends or your family, your teachers, your classmates, so that you can further develop this cool little project you've made and make it even better. At the end of the day, you're not trying to create the best or the flashiest project, you're just trying to make something that works really well and feels really nice to the people playing it. Now, one major thing to note for this project, there will be a lot of temptation to really go above and beyond with this project, make it look incredibly amazing, but that takes a lot of time and a lot of energy to be able to do. So don't go and try and make the biggest or the best game out of your different projects, because for now, this is just the first project. So try and stick to what you're learning, apply what you've learned in this project, and develop something that you can feel proud about at the end of the day. The only real limitation with this project is the amount of time that you have, and with enough time you could make an absolutely amazing game, but with the short amount of time that you have to create this project, make it as good as possible with the time that you have, and walk away from it feeling proud. With that, we'll move on to the next step. Now we have an idea of what we're going to accomplish with our personal project, and now I'm going to walk you through some of the tools that we have so that you can turn your idea into a reality. So I went over the example design document before of the project that I made myself that highlights all of the different aspects of my project.
Now, you can find a link to the example design document below this video.
And now you can see in the design document that I downloaded, it has all of this different information that I can use to figure out what information I need to create my game. Different things like the perspective of my player control, user input, the goal of the game, special effects and animation, additional gameplay mechanics. So this design document is very helpful as we structure our game throughout this process. In fact, one of the best ways that we can use this design document, and especially the project concept section, is by using this to actually break down the different mechanics of other games that we play. So whether it's a game you play on your phone, or a game that you play on your console or computer.
I feel like this doesn't matter too much. Not gonna lie. Like, it's interesting. It's not terrible. But, it seems like a lot of this is, kind of like, yeah, I might use it a little bit, or at least look at it, but a lot of this is just figure out your project, say what you want to do, etc. Yeah, I can't sketch, don't worry. And then this just recaps it. So I think I'm okay with that. We'll say, engaging instructor. There you go. Quiz 1. Now it'll ask us everything that was, on the previous thing there. And I won't know what it is. This quiz will assess your knowledge of skills and concepts learned in Unit 1. This quiz will assess your ability to navigate 3D space in the Unity editor. And manipulate, control the layout, create C#, use Visual Studio and Basic, add rigid body, declare variables, etc. Access modifiers. Well, in theory, I know all that stuff, so let's try and take it. Looks like you can take this one right away. There's no wait time if you fail, so no pressure there, I guess. Which Unity window contains a list of all the game objects currently in your scene? Currently in your scene, the hierarchy. Because the project window is everything. I mean, the scene view technically has it, but you might not be looking at everything. True or false? Visual Studio is not a part of Unity. You could use a different code editor to edit C# if you wanted to. True. What best describes the differences between the below images where the car is in the second image is further along the road? The second car's location's X value is higher than the first car's. Oh, great. The second car's Y location is higher. The second car's Z location is higher than the first car's. Wait, like this is the top? Or like... The second car's Z location value is higher. The second car's transform value is higher than first car's. I mean, I feel like that's not incorrect either. But I'll just say that for now. Public float speed 20, it's using a decimal, so it has a float at the end. What order do you put the words when you are declaring a new variable? Oh great, I have to remember these parts. I don't remember what they just find, then it's... Well, the value would go at the end like it is there. So it can't be the name one. And the name has to be in the middle for the variable name. So it can't be the top or bottom one. It can't be the top or the bottom one, so it has to be the first middle one or the second middle one. Did I write down what an access modifier is? I don't think I did. I didn't write down what an access modifier is. Data type. Data types is a strongly typed language. It means we must declare the type of a variable that indicates the kind of values it is going to store, such as integer, float, decimal, etc. Okay. So it's access modifier, data type, variable name, and variable value. Which of the following variables would be visible in the inspector? In the inspector. Well, there's only one public, so speed. What is a possible value for the horizontal variable? What is a possible value for the horizontal input up variable? I mean, it would just be up, right? I guess. Because that's supposed to, that should be the 0, 1, 0. Because you're saying the y-axis, you're telling it to do the y-axis. It's the vector 3 y up. Okay, that would make more sense. What is true about the following 2 lines of code? They'll both move an object the same distance. Yes. They will both move an object in the same direction. You can't select multiple. They will both move an object along the same axis. They will both rotate an object, but along different axes. I mean, they wouldn't move at the same distance, because they're just moving in general, so I guess they didn't want you to put that. They'll both move an object along the same axis, is what it would do, is what I would think. They'll both move an object in the same direction. That's true, though, but it's not using axis as the vocabulary. They'll both rotate an object. We know it's not doing that because it's translating, not rotating. Okay. Which of the following lines of code is using standard Unity naming conventions? So the D. Pretty sure. You need it to be lowercase, you need the F, you need the semicolon. This one has a capital S, that has a capital S, that has a capital S, that has a capital P, that has a capital F. Yeah, I think it's G. Which comment would best describe the code below? Horizontal input, get access, horizontal, rotate vector 3 up, horizontal input. Rotates around the y-axis based on left-right arrow keys. Rotates around the z-axis based on the up-down arrow keys. Rotates in an upward direction based on the left-right arrow keys. Moves object up-down, left-right arrow keys. Up and down would be vertical. We want left and right. Rotates upward, so it would rotate around the y-axis on the left and right arrow keys, because the y is sideways. Or whatever. I'm pretty sure. I don't like taking quizzes, it makes me nervous. The image below is the preferences window that allows you to change which scripts editing tool or IDE you want to use. Where would you click to choose an alternative code editing tool? A red box? Okay. Correct answers needed to pass. You just need one? What? Okay. Passed. 8 out of 10. What ones did I get wrong? I got all those right. Possible value for the horizontal input. Input access returns a float value between 1 and 1, which means your point is possible. Oh my gosh. That's so stupid. What is true about the following 2 lines of code? They'll both move an object equivalent to which has the same magnitude. You know that they're in different directions, so they would both move an object the same distance, but along different axes. It does? Oh yeah. Z is... Oh yeah. Yeah, that's right. Z is that way. X is red. Different axis. Okay, that one is my fault. Well, those are the only 2 I got wrong anyway. Introduction to project management. We might skip a lot of this too. Kind of want to just get to the gameplay part, you know? Be an epic gamer girl. Example, project design doc template. Isn't this what we already used? I mean, I guess I'll save it. I don't know. I don't know if we'll need it for anything, but I'm not planning on, like, showing this to real people. Yeah, we get it, the operation thing. Pre-production, production, post-production operations. Overview of project planning. We get that. Don't be a dummy. I mean, I suppose the point of this is to... Well, actually, I don't really know what the point of it is. It seems kind of pointless, since if I'm just one single person, I'm not going to be in a team with 50,000 people. Workspace. Preparing to publish. Quality assurance tests. Bug reports. The odd bug reports. Releasing your project. Yeah, I don't think I would have a publisher, don't worry. I'm publishing, I'm self-publishing, so... Yeah, this is more just gonna be dumb vocabulary stuff that I'm not gonna care about. This is what we want though. This is the juice of the matter. New project with primitives. Are they gonna like ask for our projects? Because they didn't ask for our projects at the end of this. We didn't have to submit anything so far. Like I was thinking, maybe we'll do this. Like it says lab 2, a new project with primitives, but the first lab showed us using the stuff from this unit, which is weird, isn't it? Why would it show the stuff from this unit if we're not even going to use it? Also, I'm just going to skip over this. Clear instructions. We want the stuff that actually gives us stuff. So, prototype 2, electric bungalow. Throw it in there. Okay, so let's get to this one, and then I think I'll take a break after I start this one up.
This prototype is all about feeding hungry animals. So the first big decision to make is what kind of animals you want to feed and what you want to feed them. Do you want to feed an apple to a chicken? Do you want to feed a steak to a dog? Want to feed some pizza to a moose? All of that and more is possible. But if we want to be able to chase all of these animals to feed them, the player is going to need some basic movement. So by the end of this lesson, you'll have a player, some food, and some animals in the scene, with the ability to move the player left and right. Moving the player left and right will be easy. We'll use the same technique we did in the driving simulator to move the car. Here's the twist though. Unlike that car, which we could drive off the edge, we don't want the player to be able to leave the edge of this screen. So to prevent this from happening, we'll use something called an if statement. An if statement is a pretty straightforward concept. If some condition is met, then do something. In our project, if the player's position is too far to the left, then we'll stop them. If the player's position is too far to the right, then we'll stop them there too. If statements are one of the most important tools for adding logic to your projects. So to make all that happen, I'll see you in Unity.
Alright, so we're going to get started with Prototype 2, and in order to get started, the first thing I'm going to have to do is make a new empty 3D project and import the Prototype 2 starter files. Now, rather than showing you how to do this step by step through the Unity Hub, since you already did this for Prototype 1, I'm just going to skip forward to the point where I've created the new project for Prototype 2 and the imported assets. There are instructions for how to do that beneath the video for you to follow in case you forgot how to do this. Okay, now I've skipped forward to where I've created a new Prototype 2 project and I've already imported the Prototype 2 starter files, so I just need to open the scene.
In my project window, in my assets folder, I'm going to select the scenes folder and open it up by double clicking. I'm going to double click on Prototype 2. So this will show us the new scene that we have for our next project. I'm going to right click on sample scene, delete, And then last but not least, I'm going to reset my layout to the new layout that I had created. So on the right side of Unity, underneath the layout button, select whichever layout works for you best. In my case, my personal layout I've created. And now we're ready to get started.
So what you're going to do is create a new 3D project through Unity Hub called Prototype 2, download and import the Prototype 2 starter files, and then open the Prototype 2 scene in your preferred layout. Now it's your turn.
Okay, well, VTuber froze again. Always don't notice it. But, oh. Well, they wanted me to make a new project again, so I have to wait for that. So I guess good time is I need to take a little break. So I'll be right back. Ah, it is that time of the day again to make more in Unity. I wonder if some of these don't import correctly because new versions of Unity. I keep getting the animation thingy. Okay. Got that up. Oh. And the player, animals, and food. One human, 3 animals, 1 food object. Into the hierarchy, rename the character player, then reposition the animals. Adjust the XYZ scale of the food so you can easily see above. Okay, I'm not gonna bother reading that one. I mean, watching that one then. Because we already know how to do that one. Okay. So, on this flat land, it's flat. So I guess we will go in here. Humans. Let's grab this one. zero it out. We can just push them back. See the import messages and animation import settings for more detail. I don't know where I see that. Well, whatever for now. We were told 3 animals, 1 food. About a moose. And a weird thing. And then we'll do a pug for some reason. We'll do a pug. Okay. And then food. Giant banana. Banana clips, though. What is this supposed to be? A carrot, yes. We'll make it a sandwich. Sandwich looks kind of boring. I'm gonna make it a steak. We can tell what a steak is. Yeah, look, we know what that is. It is a steak. Okay, rename the character player, then reposition the animals and food so you can see them. Player. Okay. I guess I'll look at this one, just in case it has anything weird.
Okay, cool. So we've got our scene set up, we've got our animals in there, we've got our piece of food, and then we have our character. So now what we've got to do next is we want to make sure that we can make the player move left and right, and so we'll need to write some very familiar code to be able to do that. What we're going to do is we're going to right-click on our assets folder, we're going to create a new folder, and we're going to call this scripts. Then if we press enter, now in our scripts folder, we're going to right-click on that, and we're going to create a C# script. Now we're going to name this C# script player controller so that we can control our player with it. And now we're going to make sure to add this script as a component to our player object. So if we just click and drag and drop it onto player, and then if we click on player, we can just make sure that we have added our script. So that's perfect. So now what we're going to do is double click on player controller, and this will open up our IDE. And now what we're going to do is at the top of our class, we're going to create a new variable, and we're going to call it a public variable so that way we can just see what it does. We're going to make this a float so then we have some really precise values. And we're going to call this horizontal input. And now in our update function, what we're going to do is we're going to get our horizontal input, and then we're going to set this to be getting the value for our horizontal input. So if we use the input manager, we can get the axis, and the axis name that we want is horizontal. Now that we're getting our horizontal input, if we go into Unity, you can see that our horizontal input has been added to the player controller script. Now when we press play, you can watch as on the horizontal input, if I press the right arrow key, it goes all the way up to 1, and if I press the left arrow key, it goes down to -1. So now what you're going to do is, in Unity, you're going to create another script folder underneath your assets folder, and you're going to make a player controller script. And then you're going to attach that player controller script to the player. And then we're going to open up our script in our IDE. In our IDE, we're going to add a horizontal input variable to our player controller.
Okay, weird. They didn't end with the move left and right thing, though. Well, anyway. I'm gonna try this thing just because I'm curious how it works. I always forget to turn that back on. Horizontal. Horizontal. Okay. Well, I can see the horizontal input. So, I guess that part works. Then we want horizontal input equals, and then it's the get access stuff. Input, get access, and I have to do parentheses, right? Yeah. I quote, oops. A quote, horizontal. Okay. And yeah, it lets me use the serious thing to do it. So then when I go to play, we should see horizontal is functioning, and it is. Huh. And everything is just moving. They don't have stationary animations, I guess. Okay. Declare a new public float. And update, translate the player side to side based on horizontal input. I don't think I need to read this one either. I mean, watch. So, we're just doing a translate. And we're doing a speed of 10. I don't know why it needs to be that, but whatever. Is that like a problem? Why is it grayed out now? Feel and float. I don't know. I don't know why it's like that. Anyway. Transform, translate. Vector 3. There we go. Right. And we want to times it by horizontal input, and then times it by speed, right? No, time delta, and then speed, because it would go too fast without time delta. delta time times speed. And then semicolon. My dog is kicking his feet against my wall. Scan me a second. And then we'll do moves player left and right. Purple. And then animator is visible. Why is that the... Oh. Oh yeah, I probably should have done that. Well, anyways, keep the player in bounds. So we can move left and right. I'll actually watch this one, because we didn't figure this stuff out yet. We didn't learn how to set bounds, so this will let us figure out the invisible wall stuff, I suppose. And that can be good if I do a little dumb walking simulator at some point.
Great, so we've added a way to be able to control the player and move them left or right. But we have another problem now where the player can actually go off of the screen that we can see. And in fact, if you see the scene view, our player can actually just go all the way off the screen. And then eventually they might actually just fall off the map, which is no good. So what we're going to do is we're going to set a boundary so that the player cannot leave this area and they'll stay within what we can see in the game. In order to do that, we're actually going to start using some logic in programming so that we can control when we want something to happen and when we don't. If we go over to our IDE, now in our IDE, what we're actually going to do is we're going to add something called an if statement to our update method. So if we go to our method and we create a new line by pressing enter, now we can type in if, and then we'll put next to it some parentheses, and then if we press enter and add a curly bracket, which is just under your minus key on your keyboard, and we'll press shift to make that curly bracket. Why? Because if we just press the button where the curly bracket is, we'll make square brackets, and that's not something that we can use, nor do we want right now. So this is an if statement. What will happen is when this line of code happens in our update function, if the thing inside of these parentheses is true, if it's something that is happening, then it'll do whatever is inside of this code block. So what we're going to do is we know that the player is moving left or right on their X position. Now we want to bound that within a certain range so that way they don't go off the screen. So what we'll actually do is in our if statement, where we're checking what's going to happen, we're going to write transform, and then we're going to get the player's position, but we're going to get the X value specifically. And we want to make sure that it's less than -10. Now there's a problem here because, as we know from before, less than is not something that you can tell a computer. If you remember, there's a lot of different symbols that you can use, like the plus sign or the minus sign. What we're going to do is we're going to use a left caret symbol. And so this means less than. So if the current object's position on the x is less than -10, now we can do something. So now that we know that whenever the player's position gets to less than -10, what we're going to do is we're going to get their position, and we're going to set it to a position that we want them to go to. So we're going to use a new vector 3. That way we can create a position that they go to. Because we don't want the player to go less than -10, we want to keep them at -10 whenever they try. So we'll put -10 for the x value, but their y and their z positions never change. So if we type transform dot position dot y, that'll get their y position, and then transform dot position dot z. And then if we close off that statement, now if we save and then we go into Unity, and now when we press play, if we try to go to the left in the negative direction, when we hit 10, you can see that the player runs into this invisible wall and they can't move any further. So going into our IDE, what you're going to do is you're going to write your own if statement in the update function to get the player's position, and if it ever goes less than -10, so say -11, just set their position to be a new vector 3 for their position to be at -10, but we don't want to change their y or their z. Now it's your turn. Keyboard.
Okay. Let's start doing it. Don't want to transform position. Dot x less than -10. Okay, that still has a comma, transform, position, we're doing y, still comma, z. So this is x, y, z. Hmm. And on Unity. This is X. And Y and Z. So it's saying if this goes past -10 or positive -10? Is that what we're going with? Well, let's do the X and Y though. Dog's groaning. Oh, that's it. Let me just test this really quick. Oh. No, let me actually test it really quick. Hmm. Okay.
So we've added a way to be able to control the player and move them left or right. But we have another problem now where the player can actually go. What we're going to do is we're going to set a boundary programming so that we can control when we want something to happen. Go over to our update, enter. So this thing inside our X position. And then we're going to get the player. Now there's a problem if you're so whenever that way we can 10 for the X valuation. When we hit 10, you can see that the player runs into this invisible wall and they can't move any further. So going into our IDE,
Oh. That's why. Okay.
great. So now we're able to make sure that the player never leaves the left side of the screen. However, the player can still leave the right side of the screen, and that's definitely not what we want to happen at all. So we're going to go back into our IDE. Now, in our player controller script, you can see that we have this if statement. And we're going to cheat a little bit, so we're actually just going to highlight all of this code, and we're going to copy it, and then we're going to make a new line, and we're going to paste it. Now, really what we're doing is now we just want to make sure that it never goes greater than 10. So, in the effort of laziness, we're actually going to just set this to be greater than 10. And then we're going to change the -10 to 10. So now, if we save this, in Unity, when we press play, if we go left, we stay in bounds. If we go right, we also stay in bounds. Now, that was a nice, easy way to be able to make sure our player stays in bounds. Now, we do have one problem where we're using the numbers -10 and 10 multiple times. And so what we're going to do is we're actually just going to make a variable for this. So that way we don't have to keep rewriting these numbers anytime that we want to. So we're actually going to create a public float. We're going to call this one left bounds so that it's the left boundary of the screen. And And we're actually just going to set this to -10 right now. And we're going to do the same thing for the right bounds. So public float right boundary. We're just going to leave these public for now, just in case we need to change the numbers later. It was a little small, the area that the player could move, so maybe we'll fix that later. So we'll actually go and, whoops, made a mistake. Remove that minus sign, because we want the right bounds to be the same as this number. So we're going to go to -10, and we'll just delete that, and we'll just call this left boundary. And then this -10, the same thing. And then for 10, it'll be the right boundary. And with that, we've just moved the values around, but the interaction will still be the same. As the player goes to the left, it'll be stuck to -10. As the player goes to the right, it'll still be 10. However, there is one way that we can do this even better than what we have right now. So you can see that we actually have 10 and -10, and we can actually clean this up to be even better than what we have right now. So, in fact, if I remove left and right boundary, and I can create a float variable that we'll just call x range to be the range that the player can move within the x value. And we're actually just going to set this to be 10. Now, the computer's mad at us because these variables don't exist anymore, so we're actually going to change left boundary, and we're going to make this a -x range, which will immediately turn that 10 into a -10. And then with our left boundary down here, do the same thing, -x range. In our right boundary, we'll set this to x range. And the same thing down in our method. And now, with this magical math that we've done, we can actually go into Unity, and when we press play, as the player moves back and forth to the left, they're stuck in -10. As they move to the right, they're stuck in 10. And now we can just change this value to say if we want this to be, let's just make this 15 for now. So instead of changing two variables in our inspector, we only have to change one, our x range. So it's your turn. Now what you're going to do is create your own x range variable, and you can set it to be whatever number that you want.
Oh, okay. Why don't they just teach you those first? Why don't they just teach you the more efficient way right away? It seems a little weird. Yeah, why don't people just use this too? It's like better. Hmm. Make sure to save. Let's just make it 20 for now. Something happening here? Why is the player being moved? Oh, yeah. Actually not sure why. What did I mess up on? Greater than their if, that's new. Have the semicolons, have brackets. That's greater, that's less. Oh. No, that didn't do it. What did I mess up on? Oh. Okay. I think that that is why. Okay. Now it makes sense. Yeah, I just wasn't saying anything. Distinct lack of talking on my part. Ugh. Focusing too much. Okay, so... Collision decisions. Random animal stampede. Destroy animals off-screen. Destroy projectiles off-screen. Make animals prefabs. Launch projectiles on spacebar. Test for spacebar press. Make projectile into prefab. Make prefab fly forwards. Play fetch. Make the projectile fly forward.
Okay, so we've got some basic interactions set up in our little game now, so we can make our player move back and forth, and they're stuck within the boundary of that invisible wall that we set up for them. So now what we're going to do is we're going to help the player feed some of these animals. So we're going to actually give this little piece of food, our piece of pizza, some forward movement so it can fly across the screen whenever the player throws it. So to do that, we're going to go into our scripts folder, right-click, and create another script, a C# script, and we're going to name this Move Forward. Now remember, always make sure you name it properly the first time. So the Move Forward script, and now that we have our script, we're going to drag and drop it onto our piece of pizza, and we'll make sure that it's properly attached, so it's been added as a component, which is great. Now we're going to open up our script. Now in our IDE, we're going to do something very familiar. We're going to create a new variable, and we'll call it a public, so that way we can change it in case we need to later in the editor. Float speed, and we'll just set this to 40 for now. So now what we're going to do is we're going to go down to our update method so that we can move that piece of pizza forward. So we're going to get the transform component of our current object, which is going to be our food. And then we're going to translate it so that we can move it in the direction that we want it to. And then we're going to open parentheses. Now we're going to move it forward in the direction that it's pointing. And then we're going to make sure that it updates over time instead of updating every single frame. And then we're going to make it move at the speed that we set up in our variable. So now we close that statement and we save our script. Now back in Unity, when we press play, we should see this piece of pizza fly straight through the air. Ooh, and there it goes. It's just flying all the way in the distance. There that pizza goes. Cool. So, to recap what we just did, so we made a move forward script in our scripts folder. We attached that script to our pizza. And then in our IDE, we made a speed variable to control how fast the pizza flies if we want to make it faster or slower later. And then we wrote a new line of code to be able to move that pizza forward over time at the speed that we wanted to using our translate method. Now it's your turn.
Okay, we can do that pretty easy. Ugh. I got the script. We're gonna open the script. Your light spiel. Private. Why does this look weird? I don't know. Oh, yeah. I'm done. I didn't type float. What do I do now? Oh. It's because I didn't... it's just because I was writing it where I wasn't supposed to write. Okay. I'm just, being dummy. Alright, what did I do now? Oh, I see what I did now. I wasn't supposed to write it there either. Why do I keep doing this? Okay. Now it's correct for once. Now it's actually correct. Okay. Now, everything is okay. Yeah, that steak be zooming. Okay, prefabs. Interesting. This part I will pay attention to.
Alright, so we make it to our pizza can fly all the way off into the distance. There it goes. Can we chase it down? Just keeps going on and on forever and ever, all the way till it reaches the ends of the earth. So we're going to stop play mode. Now, if we focus back on our main characters here, I'll just do a top-down view for now. Now, our little piece of pizza has the behavior that we want it to have, and now we need to create something called a prefab so that we can keep reusing it anytime, anywhere, and it will always be the exact same, and it'll have everything that it should be doing. In order to do that, we're actually going to create another folder in our assets. Right-click on Assets, Create a Folder, and we're going to name this Prefabs. Now, what we're going to do is, in our Prefabs folder, we're actually going to drag now our food from our hierarchy and drop it into the Prefabs folder. So now what it's asking is if we would like to create an original or a new variant of this prefab. Now, a prefab is a prefabricated version of the object that you're using. So, for example, because we want to reuse this piece of pizza, we make a prefab so that we can keep reusing the pizza over and over again, and it will always have the move forward script applied to it. Because we changed the size of this pizza, it'll always be this size whenever we bring it from our projects into our project hierarchy. Now, specifically with our original prefab, we're making a brand new prefab versus a prefab variant where, say, we had a bunch of different kinds of pizzas, but they all, are generally a pizza. Then we would start with a pizza, and then maybe one of the variants has pepperonis on it, one of the variants has vegetables on it, so on and so forth. So variants are really useful if you have a basic prefab that you're going to use, but we're just going to make our own prefab right now. So now that you have an original prefab, you can actually see it looks very similar to some of the other assets that we have. So if we take a look at the humans, you can see they all have this blue cube. So that blue cube actually denotes that these are also prefabs too. For our sake, since we made a new prefab, we added it to our prefabs folder. So, in fact, we have this piece of pizza in the scene, and if we press play, you can see that our piece of pizza flies off into the distance, just like it did before. And in fact, we can actually drag our prefabs into our scene, and they'll always have the same characteristics too. So they have that move forward script that actually makes them fly off into the distance. There they go, never to be seen again. So the way that we'll actually make these pieces of pizza spawn is actually from the player itself. So using our player controller, we can actually throw some of these pizzas by ourselves. Now what we're going to do is we're actually going to make sure that the player always has a reference to that piece of pizza. So we're actually going to go into our player controller class, and we'll create a new variable. So this will be a public, so that way we can see it and our class can see it. In this case, it'll be a game object, since instead of a value that we're storing, like a float or an integer, we'll actually be storing objects themselves. And then we'll just name this projectile prefab, so that way we know that it's a prefab that we're going to be throwing later. Now if we save and we hop back into Unity, now in Unity, when we click on our player, you'll see that under the player controller script, there's now an empty projectile prefab, and there's no game object attached to it. Now what you want to make sure you do is drag over your food prefab into that variable. So then that way it always creates a new food prefab from your prefabs. If you were to take the food that's in your project hierarchy, it would actually constantly be trying to create that piece of food that's already in your scene, and so you can actually break stuff later as you try to create more pieces of pizza. So what you're going to do is you're going to go into your assets, you're going to create a prefabs folder, drag your piece of pizza down into the prefabs folder so you can create an original prefab. And then what you're going to do is you're going to go into your IDE, you're going to create a new variable, a public game object project. So what we're going to do is we need to figure out a way where whenever the player presses a button, very similar to how they press the left or right arrow keys, they move back and forth. Whenever they press a button, they will spawn their own pizza, because we can't just be magically dragging on pizzas if our player's playing the game. It doesn't really work like that, and if 10 people are playing the game, there's only one of you, just never going to happen. If we go into our code, now in our IDE, we're actually going to create more logic. So we're going to create another if statement. So if you remember, we used our input manager to actually know when somebody's pressed the left or right key using our get axis. Now, another way that we can actually get input is if we go to our condition and we type in input for our input manager, so that way it knows whenever the player is using a controller or their keyboard, and we press dot, Now there's all of these functions that we can use, like get button up, get button down, useful if you have a controller, the get axis that we used before to see whenever the axis changes, and specifically there are these series of functions called get key down, get key up. And so these are all related to your keyboard keys. So if you get key, it gets whenever the key is pressed. Whenever you use get key down, it's whenever the key is pressed down specifically, and key up is whenever you actually let go of that key, it will do that thing. So in our case, we'll do get key down, so that way it's really instant. So whenever the player presses that key once, it'll fire off one of our projectiles. And what we're going to do is we have some different parameters that we can actually put into this method. So we have key code key, not really sure what that means yet, or we have a string name. Now, the problem is, if I want to use the spacebar, I don't really know if the string that I want to use is space or if it's space bar. I'm not entirely sure. I haven't really memorized that. So a really easy way that we can do this is something that Unity and C# already do, which is super convenient. So we're actually going to get our key code. Now, key code basically is mapped to any key on your keyboard. You can actually see in the description, it says these directly map to a physical key on the keyboard. Super helpful. So what we'll actually do is we'll type in key code, and then we need a dot so that we can find all of the different keys that are underneath key code. And you can see there's a lot of keys that we can press. There's the backspace, there's backslash, there's the letter D, there's an equal sign. So in my case, I actually just want the space bar. So you can see all the way down at S, there's actually the space key, which is really convenient. So now if we close off this parentheses, that way this is all confined within this input method. And then we're just going to add a comment for now in our if statement using the 2 forward slashes as a to-do for later. So we've made it so that we can get the player input whenever they press the space bar. So we'll remove this comment and we'll actually code how we can launch a projectile from the player. So now, whenever the space key is pressed down, something will happen. Now what we're going to do is we're going to use a new method. So this one's called instantiate. And so what instantiate does is it's another way of saying that we're going to create an object. But specifically, in our case, instantiate is for creating copies of objects that already exist. So, for example, our projectile prefab that we have at the top, we've already created that. So we're not trying to create brand new projectile prefabs. We're actually just trying to create copies of it. And instantiate is what allows you to create a copy of that object. So if we open the parentheses, you see that it's looking for an object to copy. So we're actually going to do the projectile prefab and autocomplete. And we actually need more options. So if we scroll through the different ways that we can do this, so you see here in particular, this line is really useful. So these parameters are asking for a position that the object is going to start at and the rotation that it should be when you create it. So what we're actually going to do is, since we want this to actually spawn on the player's position, we'll just use their transform position to do that. And then, since we already have a rotation set up on the prefab, we don't need to change it at all because it's only going in one direction. So we'll type in projectile, and then we'll get our projectile prefab. We'll get the transform, because that's where our rotation is stored. And then we'll get the rotation. And then we close that statement. And now, when we save, if we go back into Unity, and now when we press the play button, you can see the piece of pizza flies off to the distance as it did before. And if I click on the game screen, you can see I can move my player back and forth. And as I press spacebar, now I'm creating new pizzas, and those pizzas are flying off into the distance. So, what you're going to do is you're going to go into your player controller. In your script, you're going to add some new lines of code. You're going to create another if statement so that you can see whenever the spacebar is pressed down, we can create a new projectile prefab using the instantiate method and have it start at the player's position and oriented in the direction that we want it to be at. Now it's your turn. Okay, so we made our piece of food into a prefab, and so now we can just spawn it whenever we want. But now we should make the animals a prefab because they're actually going to be coming down in the opposite direction. So we're going to turn them into prefabs too. Now, before we make all of these animals into a prefab, it's a lot easier if we edit them and make them the way we want it before we turn them into prefabs. So we're just going to turn all these animals around, and we're going to turn them 180 degrees. So we can actually just do that in our rotation. So because we're rotating them in the opposite direction, we want to rotate them on the Y to 180. That way they turn back around. Same thing with the fox. And then finally the moose. And so now all of our animals are facing the other direction. Now, we also want our animals to move. Luckily, we've already made that script, and there's no point in making that script again because it's just going to do the same thing. The animals are just going to move forward in the direction that they're pointing. So we're going to actually add this script onto these animals. Now, an easy way to do that is if we actually select our moose and we shift click down to, in my case, the doe, you can see that all of the components that they share are already here in the inspector versus some of the other components that aren't the same. What we can do is we can actually just click and drag the move forward script onto the inspector, and it'll apply the move forward script onto all three of these animals. Now, if you don't believe me, if I click on the moose, it has a move forward script. If I click on the fox, it also has a move forward script. And if I click on the doe, there's a move forward script as well. Now, we don't want all of these animals running at the same speed, so we're going to fix this just a little bit. I think because the moose is a little bit bigger, we'll make it faster. So that way it's a little bit more difficult for the player to throw the food at it. The fox is a bit smaller, so we'll make it slower. Maybe to like 5. And then the doe, we'll set this one to 10 since it's in the middle. And now, if I position myself behind all these animals, we should see in both the scene and the game view, all of them running at different speeds. Cool, there they go. Off to the races. And then our piece of pizza, once again, flying off into the distance. So now our animals are moving forward just like our pizza is, which is awesome. So we're now going to go and create all of these animals and turn them into prefabs as well. Now to turn all of these animals into prefabs, what we're going to do is we're going to take our moose, drag it into our prefabs folder, make sure it drops right in there. We're going to make an original prefab. Same thing with our fox. And then with our doe. And now you can see all of these animals are prefabs. And the cool thing is, even though they all share the move forward script, because the move forward script itself is unique on each object, they're able to have all these different speeds. So the pizza can be at 40, the moose can be at 15, the fox can be at 5, and the doe can be at 10, because each of these is just unique to that individual animal. And in our prefabs, if we actually go to open prefab on the right, you'll see that these values were saved when we turned them into prefab, which is super helpful. To go back to our scene view, we'll click this little arrow next to the animal doe. This will bring back to our scene view. And now to really test to make sure that this works, we're actually going to remove all of our animals from our project hierarchy, so they remove from the scene. And now when we press play, as we drag all of the different animals onto the scene, you can see that they start moving on their own. And now we can drag as many as we want. It's like a little army of animals marching off into the distance as our pizza flies away. So now what you're going to do is you're going to go into each of your animal objects and you're going to turn them all 180 degrees. So we've made some really good progress. We've made all of our objects in our scene able to move. So we have that pizza that flies off into the distance. We have the animals that are marching off into the ends of the world. And then we have our player here. And if I go to the game screen, you can move them back and forth. And one of the problems that we have is we have all of these things that are able to march off into eternity. And we can even generate all of these different pizzas. And this is actually going to cause a huge problem for our game later down the line, as we have all of these different objects in our scene that are constantly flying away, constantly being updated. You can even see all of the pieces of pizza flying away. Our animals are still marching along, so they never actually disappear from the game itself. So in order to do that, we actually need to create a way to remove them from our game when we don't actually see them in what the player should see. How we're going to do that is by creating another script to be able to manage that interaction. So we're going to go into our scripts folder and right-click, create a C# script, and we're going to call this script Destroy Out of Bounds. Definitely a very long script, but make sure that it's named properly. And now what we're going to do is we're going to take Destroy Out of Bounds, and we're going to add this script onto our piece of pizza in the scene. And then if we click on the pizza, we just make sure that it's attached. Perfect. Now, if we open the Destroy Out of Bounds script, now we're going to use an if statement to check whenever our piece of food flies out of the bounds of what we can see on our game screen, it'll delete that object from the game. So if we use an if statement, and we'll leave the conditions for now, and then we use those curly braces. So we want to get the current object's position, so we'll do the transform to get that, and then get their position. And since everything is happening on the z-axis, we'll get the z of our piece of food, and if our food flies greater than, let's say, 50 for now, there's a really helpful method that we can use in C# called destroy. Now, destroy actually enables us to remove a game object, we can remove components, we can remove assets, and so we'll use destroy to remove the game objects on the screen that are no longer actually within view of our player. In this case, since we're actually calling the object itself, we can just use lowercase g, game object, and this will be the current game object that this script is applied to. So now when we save, if we go into Unity, and let's position our camera a bit better to see where the pizzas disappear. So when we press play, if we watch the pizza, flies off into the screen, and then it deletes right about there. So we can probably make it a little bit less. So we'll set this to, let's call it 30. And in fact, we're just going to make a variable for this just in case we need it for later. So we'll call it private, since we know just about the size that we need it to be. This will be a float, and this will be our top boundary, so top bound. And then we'll just say 30. And then we'll change this 30 to our top bound. And save. Back in Unity, we can watch the pizza. And when they fly to the top boundary, we can even expand the game scene. Oh, that's weird. I think we broke something. You can still see the pizzas flying off. That's strange. How come that didn't work? Well, remember when we made prefabs? So we created this prefab on this pizza, and we have the destroy out of bounds script. However, adding the script to this object in the scene doesn't actually update all of the prefabs. In order to do that, there's actually a little button over in the top right of our inspector called Overrides. And if we left-click Overrides, you can see that it actually tells you that something's different between this piece of pizza in the scene and our prefab itself. And so the destroy out of bounds script is actually new. So if we apply this, now all of the pizzas that we create when we instantiate them should have that script applied. So one more time. Pizza flies off, disappears. More pizzas, and they all disappear. So, perfect. Now we don't have a million pizzas flying off into the distance. So, now what you're going to do to be able to destroy all of these pizzas in the scene is you're going to create a new script called destroy out of bounds. And then you're going to apply the destroy out of bounds script onto your piece of food. And then going into your IDE, on the destroy out of bounds script, you're going to set a variable for the top boundary. And then in your update function, you're actually going to use an if statement to see whenever the piece of food flies out of the boundary, you're going to destroy that game object or that piece of food. And then in Unity, you're going to make sure that you go to your piece of food, click Overrides on the right side, and then make sure that you apply your override to make sure that all the prefabs you create all have this script attached. Now it's your turn.
Well, that has been an experience. I think I can do this part on my own. It's just repeating the same process. Overriding the prefab. I want to make a... Always wondering how people did it. So this would be if the position is greater than lower bound. So we want, if it's less than, So then we just need our prefabs. Industry. Yeah. Okay. Now all these prephones have them. Yep, all of them get destroyed. Okay. Okay. Huh. Clear instruction. We all good. Create a spawn manager. Spawn animal if S is pressed. Spawn random animals from array. Randomize spawn location. Change the perspective of the camera. Lesson recap. Okay, so I might just do what I just did earlier. And just try and quickly go through these, listen to the videos for stuff I don't know, and just write along and see if I get it. And we'll talk about it after. So, let's get into it.
Awesome. So our project's in a really good place right now. You can see when we play our game, as our food and as our animals leave the scene and leave the player's view, they get removed. Same thing whenever we create these pizzas on our own. Now, one of the things that we have to fix is we need to be able to make animals spawn in our scene, and we need to be able to make it do randomly, so that way it's a little bit more challenging. So we're actually going to use some code to be able to do that. So what we're going to do is we're going to go into our project hierarchy on the right side. We're going to right click in the hierarchy and we're going to create empty. Now we've created an empty game object and we'll use this game object to actually store our script. We're going to actually call this game object our spawn manager because this is what we'll be using to actually manage all of the spawning of all of these animals on the screen. Now, we're going to need an actual script to be able to spawn all of these animals in random locations in our scene. So in our scripts folder, we're going to right click on it and we're going to create a C# script. And we're going to call this script our spawn manager. Now, we're going to attach our spawn manager script to our spawn manager game object. And so if we click on the spawn manager, You can see that we've now attached this script to it. You can see where our spawn manager is in our scene, right in the center. It's invisible because it doesn't actually exist, so you can't see it on the player screen, but we know it's there, and that's how we'll be making all these animals spawn. So if we double click on Spawn Manager, now our Spawn Manager script opens up in our IDE, and what we're going to do is create a new variable. Now, just to see what this game object does, we'll make it public for now. And we'll make this a game object because it's supposed to store our animal. And now what we're going to do is we're going to use something called an array to store all of the different animals that we have. Now, the way that you would use an array when you're programming is you would actually use our square brackets. So instead of pressing Shift to create those curly brackets that we would use in all of our statements, instead we're just going to press the square brackets, and these two side by side means that we've created an array. Now, an array in programming is something that you can use to store multiple objects, multiple variables inside of. So say we had something like a bookshelf and we had 4 different shelves. And so those shelves we would use to store all of our books onto. We'll call this array animal prefabs, so that way this array stores all of our animal prefabs that we've created. Now, the way that you would read this line is that we have a public game object array of animal prefabs, or an array of game objects which we'll call animal prefabs. An easier way to see this is if we actually go back into Unity after we save. Now, in Unity, you can see that we've created this public game object in our script. And if we go to our Spawn Manager, underneath Spawn Manager, you can see this animal prefabs drop down. So if we expand it, now you can see that's asking us for our size. So this is the number of items that we actually want to store in our array. So for example, say we want to store 4 items. It'll ask us what 4 things we want to store.
Now, if you're in a newer version of Unity, the size field will actually be over here if you want to enter the number manually, or there's this little plus and minus button that you can click on to add or remove items one at a time in the array, but it's basically the same.
All of these different elements are all of the different boxes that we can put our game objects in. If I were to change this to something like 3, in Unity, it would actually change the size of our array as we need it. Because we only have 3 animal prefabs, we only need to make the array a size of 3, so then that way our array can store 3 different game objects. So what we'll do is we'll left click and drag each of our prefabs into one of those element boxes. And now all of the animals are stored in this array that we have in our Spawn Manager script. So what you're going to do is you're going to create an Alright, so we've created our Spawn Manager and given our Spawn Manager an array so that we can hold each of our different animal prefabs. But that doesn't really do us any good because we can't actually spawn anything now. So we're going to create something in our code so that we can actually spawn these animals. Going into our IDE, inside of our update method, we're going to use an if statement like we did before to create all of the different pieces of food that we were throwing into our scene. And we're actually going to use a key code to be able to spawn all of those animals. So if we use our input manager, we're going to get the key down for when our player presses a key. And this time we're going to use another key code. And we're just going to use S on our keyboard because we're not going to use that to move right now. And then if we type our curly brace and press enter, So now that we've created a way to actually get player input to be able to spawn these animals, we now need to actually spawn these animals. So we're going to use the instantiate method that we used to be able to create all of our different pieces of food. And we're actually going to use our animal prefabs array. Now, in Unity, the way that we're going to pull each of the different elements from our array of animal prefabs is actually using these elements over on the side here. So you can see element 0 is the animal doe, element 1 is our fox, and element 2 is our moose. So in our code, each one of those numbers is actually how we can call each of those different animals. So, for example, if I use 0, this should give us our doe, and now we're going to need a place to actually create this animal. So in our case, we're just going to spawn the animal just above the screen that the player can see. So using a vector 3 for our position. We don't need it to be anywhere on the X. We don't need it to be flying in the air on the Y. And since our top bound was set to 30, we'll just spawn the animals at 20 for now. And we need to make sure that the rotation of those animals is properly set up, so we'll use our animal prefabs again. Use those square brackets, and we'll use 0 for now, and then we'll get the rotation of that animal. So if we save, and we go into Unity, so our doe is element 0, and when we press play, and we press the S key, you can see that a doe spawns every single time. So in our code, to make this a bit easier to control and so that we don't have to keep using this 0 every time, we're going to make a new variable, and we'll call it public for now so that we can interact with it in Unity. Now, in this case, we're actually going to make this number an integer because it has to be a whole number. If we actually try and use a float, then our array will get very angry at us. And we'll call this the animal index. Now, in an array, each of these different numbers is actually called the index. And so, in this case, because we didn't assign this a value, it'll just be 0. So we can just remove the zeros. And then if we save, now in Unity, you can see that we have our animal index here. So when we press play, whenever we press the S key, you can see that does spawn in the scene. If we change our animal index to 1, and we press S now, we have these foxes that spawn. And when we change our index to 2, it'll be pulling from element 2, so we should have mooses that spawn. So now we have a whole herd of moose going down the screen. One thing to note is if we make the animal index 3, and now if we press S, you can see all the way at the bottom of the screen that we're actually getting an error. You can tell it's an error because it's got this big red exclamation point and all the text is red. And this is telling us that the index was outside the bounds of our array. Now, because we don't have an element 3, and we're trying to get an element 3, our array doesn't like that. However, if we put this back to 2, and now if we spawn animals, it works perfectly fine. So always make sure that you keep your index inside the size of your array to call the proper element. So now what you're going to do is in your spawn manager script, you're going to create another variable for the animal index so that we can find each of the different elements in our array. And then in our update method, you're going to create an if statement to get the key down whenever the player presses the S key. And when they do that, you're going to use the instantiate method to create an animal prefab using the selected animal index. You're going to spawn it at 0, 0, 20, and then you're just going to make sure that the rotation of the animal is the same. And then in Unity, to test it out, you're going to go into play mode. And then when you press S, you should see animals spawn. And if you change the animal index to 0, 1, or 2, then you'll see different animals spawn. So, now it's your turn.
Sorry, when I'm in that mode, I get distracted. Feel like I hurt my thumb. I don't know how, but hurt it somehow. Spawn random animals from array. But why do they spawn so far away? Like they're spawning in. They're spawning in from further away than I think. I don't know why. Oh. Okay, now I know why. They spawn there. Oh, okay, I get it now. I understand. It's because you're telling the vector where it's spawning from. So it's spawning at the 30. Okay. That makes more sense now. I was just being dumb. Huh. Okay. So if I change this to negative 12. Okay. I think negative 14 is probably what I want. Not that I really need it, but why not? Okay, that looks better. I just wanted to destroy itself out of frame. Anyways, I'm doing fine enough. I'm just trying to learn Unity. I did the Essentials course, and now I've been doing the Junior Programming course. currently on Unit 2. And I guess now I'm going to learn this random animal stampede thing, so uno momento.
So we've made it so that we can choose one of the different animals to spawn from our spawn manager by using the index to select one of the animals in our array. Now, there's a better way to do this to be able to randomly select an animal that we need so that it can choose an animal without us telling it which animal we want. Now, what we're going to do is we're actually going to use another method in Unity called random. Now, before we get into randomly selecting which animal that we want to choose, we're actually going to rearrange our code to make it a lot more structured and organized. So, in the past, we've always put our variables at the top of our scripts. What we're actually going to do is we're going to take our animal index, and if we cut it with Control or Command X, and we go into our if statement and create a new line, and then we paste that line of code. Now you can see that our animal index is down inside of our method. We can actually remove this public. Now, where you put your variables in your script matters a lot. Typically, if you have a variable that you're going to use throughout your code, you should actually put it outside of any method, so that way I can actually use the animal prefabs down here in update, or I could use animal prefabs here in start if I wanted to. We've moved our animal index down into our update method. So the animal index variable can only be seen within this method. In fact, if we try to type in animal index into our start, our method has no idea of what we're talking about because it doesn't exist. Versus if we type in our animal prefabs, you can see that it auto-completes for our prefabs. So now, in our animal index variable is where we'll be selecting a random number that we can then use to select a different animal prefab from our array. Now, we're going to use something called random, which is a class used to generate random numbers. And we're going to use a method called range. And so this will pull a number between the first number that we select and the last number that we select. So in our case, the number that we want it to start at is 0 for the first element of our array, and then we're going to set it to 3. Now, it's important that it's set to 3 because it will actually count through 0, 1, and 2, but it won't use 3. The 3 is what we call an exclusive number, and so it won't actually use that number, but it will use it as the maximum number that it will go up to. So now if we save this, and if we go into Unity, and we press play, now whenever I press S, a random animal should spawn between the 3 different animals we have. So now that we know that that works in our spawn manager script, we can actually clean this up a little bit. A really cool feature of arrays is that it can actually track the length of how large it is itself. So if we type animal prefabs for our array, and we type dot, we can get the length of the array. And since the length of our array is a total of 3 elements, it'll actually set it to 3 itself. So if we save once again, in Unity, when we press S, different animals will spawn using our
Well, that's pretty interesting. Randomize the spawn location. I figured this would be it. So they just move it, or oh no, they actually make a spawn range. Interesting. I feel like at that point it might be easier to just copy and paste the thing, but I guess technically it would be easier to do it this way if you could. At least easier on the system, because you'd have less files. It's always weird to see how it actually functions in practice. But I'll be quiet again really quick.
Alright, so we've made it so that we can spawn all of these random animals, which is awesome. The problem is that they're all just spawning in the same place, and that's definitely not what we want to happen, so we're going to use random again to move them around our scene. Now, to get our animals to spawn in random places, we're going to go down into our update method, where we actually set the position of where we want them to spawn. Now, for this 0, because we don't just want them to spawn in the same place on their x-axis the entire time, we're going to use a random range here. And for now, we'll just set it to be between like -20 and 20. That way it has a wide area of which it can spawn all of the animals. Now, if I save this and I go into Unity when I play my game, now whenever I press S, you can see that all of the random animals are now spawning in random positions, which is awesome. That's exactly what we want. Now, our instantiate method is getting a little bit messy down here. You can see that we have our animal prefabs array, but then we have this huge line of code right here. So we're actually going to create another variable inside of this method for this. So underneath our animal index, we'll create a vector3 variable, since we're trying to store a coordinate. And we're going to call this the spawn position, or spawn pos. And in here, we're actually going to just take this entire line for our vector3 that we generated randomly. We're going to cut that with Control or Command X. We'll paste that into our spawn position. And then we'll replace what was there with our new spawn position. And so now we're just using a variable to be able to store this line of code right here. One small thing that we can do better is we're reusing these numbers a lot here. And so we know that in our random range, this -20 and this 20 is the range of our x that our animals can spawn at. So we'll create a variable, private float, so that we can get very precise numbers that animals can spawn at. We'll call this our spawn range for the x, and we'll just set this to 20. And then we can remove this -20 and 20 to be spawn range x. And then since we know that in our spawn position that we're always going to be spawning things at 20 on our z, we can just make another variable for that. And then we'll remove this 20. And so now we can use variables to make our code a lot more readable and make our lives a little bit easier, especially if we ever want to change our x values, or if we want to change our z value to maybe spawn a little bit higher. Now we can easily do that, and we don't have to change all of these numbers all at the same time. So now it's your turn. You're going to create 2 new private float variables for the range of the x and the position of the z that animals will spawn at. And we'll set both of those to 20 for now. And then down in our if statement of our update method, we'll create a new vector3 spawn position variable, which will use our random position that we were generating down in our instantiate method. So we're just going to cut all of that out and paste it here. Change the -20 and 20 to negative spawn range X and spawn range X. Change the 20 for the Z position to spawn position Z. And then use spawn position where we were using our new vector3 with the random range. Now it's your turn.
Oh, I was doing it wrong. I understand though. This is kind of neat, learning how to do this part. Well, let me take a second to make this code not terrible. On pause. Oops. Initiate animal index. On pause. Comma. Semicolon. Transform rotation animal index. Yeah. Okay. I see my mistake. I was doing it too fast. I was being a dummy. Though we're still setting it to S, aren't we? We never changed that. Yeah, it's still S. Well, even if it's still set to S, now when we're in here, it still changes the location. Oops, I'm still in game. Still in game. I just wanted to use goat for reference. We're going on a range of 20s. That spawns there. And there. Oh, I'm dumb. Okay, it looks like we want to do 15 instead then. The range on the x-axis though. That one's fine. We just want to change the x-axis. Okay, so we'll just change the x-axis 1 to 15. And then I can just yeetus deletus that one. And now when we hit S, I can mostly see them all. Looks like I might need to make it a little tighter still. Oh, is it because it just set to that automatically? Didn't I save it? I guess when it's public it just stays like that until you change it on the public thing. I don't know. Weird. And then we can go boo 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 boo. A lot of mashing. Well, it works. That's always neat. Okay, so we got that done. Change the perspective of the camera. Toggle between perspective and isometric view. The scene view to appreciate the difference. Select the camera and change projection from perspective to project. What does any of that mean? Hang on 1 second, Digimon.
Alright, so our game is coming along really nicely. You can see all the animals as they spawn. You can spawn them in random places. We have different animals spawning. We can throw our food. And no matter how many things we create, they all get removed from the screen when they leave the player's view, which is perfect. Now, we can actually mess around with the camera a little bit. So some cool things that you can do, especially since this is a top-down game, so it's kind of 2D-ish. Now, say you want to kind of see what this perspective was like in our game, in our scene view. So you might notice underneath the little tool that helps us change the different sides that we can view from our perspective, we have this tool over here that enables us to shift between what's called perspective view, which is what we're at right now, to isometric view. So you can see that everything turns a little bit flat. So if we do that again, so you can see right now we're in isometric view. And if you watch any of the animals, you can see that they actually develop a lot more definition and depth on the side versus if we do isometric, where everything turns flat. Now, to do a similar thing within our game view, we can actually manage that through our main camera. So if we click on our main camera in the hierarchy, you can see underneath the camera settings, there's a projection variable. And if we left click on the drop-down, you can see perspective, or we can go to orthographic. Now, if we click orthographic, you can see that all of the animals become flat again. But you can see that they still have shadows because there's still depth and light involved. And so shifting between perspective and orthographic is a really cool way to get different kinds of detail in your game if you're looking for a certain kind of feel. So just make sure you save whichever way that you want your camera to be, and then take it from there. So what you're going to do is in your scene view, you're going to take a look at what the scene looks like from perspective versus isometric. And then you can achieve the same effect in your game view by going to the projection of your camera and going between orthographic, which is more flat, especially if you have flat 2D games, or perspective, which brings back the depth of all of our 3D characters and models. Now it's your turn.
Well, that's weird. The isometric view kind of looks cool, but gimmicky cool. Not actually cool. And that's just the lesson recap. We don't care about those. Recaps? Who needs those? We probably do, but it's okay. Collision decision. We'll spawn them on a timer. This is what we're talking about. This is the real stuff. And destroy object on collision. On the unwanted timed intervals. Okay, so this is more or less making an actual game. Even if it's a little baby game. Actually making a game. I like how this project outcome is. If the player hits them with a projectile to feed them, they will be destroyed. Well, I guess I'm not really feeding them then if they're just gonna die, right? Make a new method to spawn animals. Okay, so let's just get right into the nitty-gritty of it. I think I'll try and just blast through this also, so I can maybe get to bed before I... Well, hopefully I could get to bed like at like 12 and finish the stuff. That'd be nice, but we'll see. Finish it before midnight. It says 50 minutes. Let's do it in less than 30 by listening.
Alright, so our project is looking really good right now, so we can actually create a whole bunch of different animals by pressing S. But if we want our game to spawn all of these animals automatically, we're going to actually have to write our very first custom function. Now, in our spawn manager class, we're going to write our own function, very similar to the functions that you already see here, start and update. Now, start and update are actually functions that come from the mono behavior class. Up until now, we've never actually written our own functions to be able to do things that we need them to do. So we're going to do that now. What we're going to do is we're going to type in void. Now, void tells the computer that this function or method does not return anything. So it just does what we tell it to do inside of this block of code, very similar to what the update function is doing in this block of code. So it's just going to do something that we need it to do. Now, when we're creating our own custom functions, we should name it in a way that it tells us the task that it's doing. So in this case, we're actually going to create a custom function that tells us to spawn a random animal. And then to close it off, very similar to our update or start functions, we'll just use parentheses. And then if we press enter and use the curly braces, now we can add whatever blocks of code that we need inside of this spawn random animal function that we've created. In fact, we've already written code that will allow us to spawn a random animal. You can see inside of our if statement that we already wrote all of the code that we need to spawn a random animal. So what we can actually do is just take out this entire 4 lines of code and just put it into our spawn random animal method. So if we highlight all of those lines, and then we Control or Command X to cut it, and then in our spawn random animal function, we can just paste that in there. And now, every time we call the spawn random animal function, it will automatically go through these 3 lines of code to be able to create a new animal at the end of it. If we go into our if statement, we can now just type in spawn random animal. And now every time we press S, our update function will call spawn random animal. Spawn random animal will then go through this line of code to create a random animal index, and then it will get a random position to place that animal at, and then it will call the instantiate method to be able to actually create that animal. By creating your own custom functions and methods, it makes your code a lot easier to read and manage. By making sure that certain tasks that you need only for a specific purpose are kept inside of one specific method, and then you can just reuse that method over and over whenever we want to spawn an animal for any use later. So just to make sure that our spawn random animal method works, what we're going to do is we're going to go into our game, and you can see that we're playing, and when we press S, there you go. So it's doing exactly what we did before, which is nice, but now our code looks a lot cleaner. Great, so we've added our new custom function to our spawn manager. So when I play the game, when I'm pressing S, the animals still spawn randomly, which is great. Now, what we need to be able to do is spawn the animals on a timer, so that way we don't have to press S anymore. Now, we're going to use a new method this time called invoke repeating, and we'll actually put it inside of our start method. And so, what invoke repeating does is it will actually take a method that we want to call, and at a certain time, we'll start to call that method, and then we'll constantly repeat it over time depending on whatever rate we want to use. So in our case, we can actually just use strings, so we'll call the string, and it'll just be the name of the method we're using, so spawn random animal. Now, we need to give it a time to start at, so we'll just say 2 for now. And then we actually need the time that it will repeat every single time. So we'll just say 1.5 seconds that it'll repeat. So the way that we read this method is that we'll repeatedly call our spawn random animal method starting at 2 seconds, and then we'll call it again every 1.5 seconds. In fact, now that we have this, we can actually just get rid of this input that we have by pressing S to spawn a random animal. Now, if we save and we go back into Unity, when we play our game, let's hope that this works. There you go. You can see that we have started spawning animals, and every 1.5 seconds, we're going to have a different random animal spawning, which is perfect. That's exactly what we wanted to happen. So we'll stop playing for now. Now, one thing that I do want to show really quick is in invoke repeating, if we type spawn random animal and say we accidentally used a lowercase letter, like our lowercase s, and then we save this, and then in Unity, if we tried to do that again, so you can see at the bottom, Unity is actually saying that it's trying to invoke a method that can't be called, because actually that method doesn't exist. So it's always important to make sure that you properly capitalize things whenever you're typing. So now what you're going to do is you're going to use this fancy new method called invoke repeating, and we're going to use that to call our spawn random animal method. Make sure it's a string, so you use those double quotes. So back in our spawn manager script, we're going to just fix the S on spawn random animal. And we don't like having just these numbers in our code, so we're going to turn these into variables too, in case we want to change the numbers at some point. So we'll call this private float start delay. That way we know how long to wait until we start spawning animals. And I think 2 is a good number for now. So we'll make another private float, since we know this has decimals. And this will be the interval that our animals spawn, so spawn interval. And I think 1.5 was fine, so we'll keep that for now. And then we'll change the 2 to start delay. And then the 1.5f to spawn interval. And then make sure that you close those statements. So what you're going to do is you're going to create 2 new variables for our start delay and our spawn interval. And then you're going to use this fancy new method called invoke repeating to call our spawn random animal method with our start delay and our spawn interval. And then you're going to remove all of the spawn code that we had in our update method, since we'll just be using invoke repeating. Now it's your turn. Okay, so we have it so that our spawn manager is spawning all of these animals in random locations. You can see them as they run down the screen. Now the problem is that we can't feed any of these animals any of this food that we're throwing. What we need to do is we actually need to have them detect collisions whenever this piece of food runs into these animals. And we're going to use something that should be a little bit familiar called colliders. So what we're going to do first is we're actually going to double click on one of our animals. And so now you actually see that we're in our prefab preview mode. So we can actually just see our prefab instead of seeing our actual scene. And this is where we can actually make changes. So if we made a change to this prefab and say we had 50 of these dough already on screen, it would automatically apply all of those updates instead of us having to go to the overrides and then apply all in the top right. So what we're going to do is with our animal prefab, we're going to go to add component. And we're going to type in collider. Now you can see we have all of these different collider options. In our case, a box collider is probably good enough for what we need. Just be careful, especially to not select Box Collider 2D. That's specifically for 2D games, and even though this is top-down, we still have 3D objects, so we should be using a normal Box Collider. Now, the cool thing about using our prefabs preview mode is that we can actually autosave whenever we change things. So we added this collider, and it automatically saved our prefab, so that's cool. So we're going to use these perspective views to just get a better angle on our dough over here. So let's give it a side view. We'll just line this up really quick. Now we can edit our box collider in one of 2 ways. We can go and change the values of our size here, either by grabbing the number or just changing the number itself. Or we can use this edit collider button, which is super useful. So that we have this side view, we can get like a general estimate of how large we want this thing to be. So you see these dots on the box now, so we can actually just click and drag these dots. We can get like a pretty good estimation. And then we'll bring the top down a little bit, and then scroll this out a bit more. Do that. And let's do like a back view just to see about there and about there. And so if we fly around our dough, you can see it's pretty close, honestly. It's good enough. It's good as it's going to be. So now that's already been saved. One thing that we want to do, uncheck the Edit Collider button and make sure you click Is Trigger, because this collider will actually be a trigger for when our piece of food hits one of the animals. Another thing to make sure is maybe you accidentally click on the dough as you're editing. All you have to do is go back to the very top animal at the top of the hierarchy, and it will highlight your animal, and you can see that your box collider is already applied there. So we've added this collider, we can autosave, and we can go back. And now if we actually look at our dough now, we change the preview of the prefab, but it already has a box collider. A quicker thing that I like to do just to make things faster and I don't have to click into prefabs all the time is as I'm setting up all of these different characters and objects, I just leave them on the screen, and so I can actually edit our collider here if I wanted to. add a box collider, edit the collider any way that I want to make it smaller, and then I'll override it so that I don't have to keep going in and out, and then it'll just apply it to all the prefabs. And then when I'm done editing all of those different assets, then I can just remove them from the scene, and since they're auto respawning, it makes it really easy. So I'm gonna edit all of these animals really quickly, and then we'll go back in. Cool, so I'm down to my moose now. I've already set up the collider to be properly sized. Just make sure to click is trigger, and then afterwards, since this is an object on our scene, we're just going to override it so all of the moose prefabs get that collider. So with all of our box colliders applied, and we've applied the triggers to all of them, the reason why we added triggers is to be able to detect when another object collides with this box. So for example, with our food, when the food enters this box collider, the box collider will know that something has entered this space, and then we can actually, using code, have our animals be removed from our game when that happens. The last thing that we're going to do is we're going to go into our pizza, and in this case I'll actually just go directly into the prefab, and we're going to go and add a box collider in here. Perfect. And then this will be a trigger as well, so that when it collides with something, it knows, and it'll be deleted. And then one thing that we do have to do is colliders actually require a rigid body to be able to detect a collision in our physics. So if we type in rigid body, and we'll apply a normal rigid body, not a 2D rigid body. And since we want our piece of food to fly through the air, we're just going to turn off gravity so it doesn't fall through the ground. So now using physics, we'll be able to detect, because of this rigid body, whenever this piece of food enters one of the colliders of one of our animals, and then we'll be able to delete the animal because something entered its collider, as well as we'll be able to delete the piece of food because something also entered its collider. So now what you're going to do is you're going to go onto your different pieces of food and animals, and in their prefabs, go in, make sure to add a box collider on each of them and check the is trigger box on all of them. And then for our piece of food, just make sure that you apply a rigid body to it and make sure to uncheck that it's using gravity so that it does not use gravity. Now it's your turn. Alright, so on all of our animals, we have added each of these box colliders that have triggers on them. We've done the same thing with the piece of food, as well as added a rigid body to it. Now we're going to create a new script so that we can destroy any of these objects whenever they collide using code. So we're going to go down to our projects window, in our scripts folder, create a new script, and we'll just call this detect collisions. Now we're going to add the detect collisions script to all of our animals and our food. And then just make sure to apply those scripts if you didn't do it on your prefabs. So now that we have all of our detect collision scripts attached to all of our different objects, we're going to open up the script by double clicking. Now in our script, what we're actually going to do is, instead of using start or update, we're going to go underneath start and update, and we're going to type in void. But instead of creating our own function, we're actually going to override a function that already exists in the MonoBehavior class. So we know that start and update are both functions from that class, And we can actually use functions from that class to be able to do things that we want it to do. So if we type in capital O, N for on, capital T, R, I. So you can see here that my autocomplete tells me to use on trigger enter. So I'm just going to press enter on that. And so it'll automatically fill my on trigger enter method. You can see when it auto-completed that it already made this method private so that it's only available within this class. And then it also automatically gave us a parameter that we have to fill in whenever it happens. Now, because of the way that this method is set up, it actually is already pulling all of that information in from MonoBehavior. So what happens is in Unity, whenever one of the colliders collides with one another, it'll actually know from this script that they've collided and it should do something. So in onTriggerEnter, we're going to type in destroy, and we're going to destroy this game object. Something we're very familiar with now. So if we save and then we test, so if we watch this food and this fox over here, you can see that the fox immediately eats the food, which is great. Now in our IDE, when our food collided with the animal, it destroyed itself. And in fact, it also knows that it collided with that other animal. So in fact, we can destroy other, which in this case will be the animal that it collides with. And then we'll destroy that game object. So now when we test again, when we're in Unity and we play our game, when the food and the animal collide, they're both removed from the game as well. And then we can actually see if these collisions work. Yep, there you go. So it works on the dough. And one more. Cool. So now what you're going to do is you're going to create your own detect collision script. And then you're going to apply that script onto each of the animal prefabs. And then you just want to make sure that they're all attached. And make sure you also add it to the food as well. And then in your detect collision script, you're going to create your own overridden function called onTriggerEnter, which actually comes from the MonoBehavior class. And then in that method, you're going to call the destroy methods to destroy the game object and then destroy the other game object. So that way, when both of these things collide, they're both removed from the game. Now it's your turn.
Well, it's certainly been interesting so far. I ended up letting that one wait. I always tell you to wait, then do. But I've been doing and then waiting. Alright, collide with other. Then we write our script. Destroy game object. And then destroy other game object. Okay, well, let's see if this works in motion. Yeah, they destroy each other. That's pretty cool. Okay. Well, what else do we got here? I didn't think this destroy thing would be that easy. But it's just like, you know, the one-line code. Write that down, just so I know. Okay, trigger a game over message. Debug log game over.
Alright, cool. So we have all of the collisions set up in our game, which is awesome. We have this little bounding box problem, but we'll fix that later. Can't actually feed any of those animals. And the doe, and we got one of the animals, and this fox. Cool. So we have the collision set up properly. Now, one of the problems that we have outside of that invisible wall is that we can't actually end our game if any of the animals get past the player. So we're going to add a small thing to fix that just to show us that the game is over. So one thing that we're going to do for cleanup, since we know that the spawn manager can spawn all these animals now, the player can spawn their own food, and all of the collisions are set up, we can actually just remove all of these different food and animals that we're using just as placeholders while we edit them. So we'll select all of them, right-click,
Oh no, I already
and
did
just
that.
delete. So in order to tell us that the game is over, we're actually going to go into our destroy out of bounds script. So in our destroy out of bounds script, you can see that we have a destroy object whenever the piece of food goes past the top. And in our else if, we actually have a really nice place where, since the animals get past the player, that's a good place where we can end the game. So the way that we're going to tell ourselves that we can end the game is by using something called debug.log. And in debug.log, we can actually just put in a string. So we'll just type in game over. And if we save that, so what debug.log will do is actually in Unity, it will tell us at the bottom where it logs all of the different errors or warnings in Unity. Whenever an animal gets past us on the screen and they get destroyed, it'll tell us game over. So if we just wait for an animal to go by, there goes that moose. And in the bottom left, you can see it pops up game over. So debug.log is a really great way to be able to tell yourself something whenever you want something to happen in Unity. So for example, for collisions, if we wanted to know that a collision happened, we could use debug.log to see if it actually happened in case we needed it to. It's very helpful if you ever need to see if something is happening the way you want it to. As another last bit of cleanup, what we're just going to do is we're going to add in some comments to our code to make it readable. So for example, 2// if an object goes past the player's view in the game, remove that object. So we're just going to go into the rest of our other scripts now and just make sure that we add comments for wherever it would be helpful to just understand what's happening in all of these different places. Something else that you can do is in places where you see especially messy code, maybe you can write new functions to be able to handle those things. And then if you end up having some really crazy formatting, a really easy way that you can fix that. For example, if I just, let's put that there and we'll just go over here or something. And then we'll put this all the way next to this brace. If you go over to Edit in the top left if you're in Visual Studio, if you go down to Advanced, and then you see this option here called Format Document, if we press this, it'll actually reset all of the weird spacing that we had to make our code a lot more readable. So what you're going to do is you're going to tell yourself that the game is over by using a debug.log statement. And then you're going to go into your code, add in some comments. If you have some really weird formatting, like weird spaces or something like that, to help make your code readable, you can go to Edit, Advanced, Format Document if you're in Visual Studio. And then last but not least, just make sure that you remove all of your animals that are in your scene hierarchy, since we know that all of the code that we've written now works. And now it's your turn.
Well, that was another enlightening one. Another enlightening one. This one's another hour, so I think I'll end here. Warning, dogs are spawning at the top of the screen. Players spawning green balls instead of dogs. Balls are destroyed if anywhere near the dog. Nothing is being destroyed. Screen, only one type of ball is being spawned. Spawn interval is always the same. The player can spam the spacebar key. Kind of weird that this doesn't have, like, these challenges don't even have the submission thing. Find that part weird. Oops. Hitting save on there, not my project. But yeah, I think I'll end here. I don't need to do these projects technically. Could just grab the EXP or whatever. Go on to the next stuff. Because we just need to take the quiz and then we can go on to the next mission. Beyond the new project parameter stuff. But I feel like it's good to get through this stuff and just reiterate it to myself, pound it into my head. So I'll still do this, but we'll take care of that tomorrow. So we got through a few more missions. We're almost through the first mission of Junior Programmer, and then we'll get the second one. I don't know what it'll be, but it'll be interesting. Either way, I'm gonna go for now, so for anyone who dropped in, thanks for watching. Hope you enjoyed. And I'll keep learning. I'll keep writing some more. Hopefully I'll be able to stream a normal video game at some point. Unless I'll just stream me making video games, who knows? Oh. Glad I started on my novel. Got a new story going. And I learned some more Unity. A very productive day, I would say. But anyway. Bye. That was the wrong one.